Hello everyone, I am Mariko Toda from Kokusai Kogyo. Thank you for inviting me to this event today. It would have been nice if I can visit Taiwan and meet everyone directly, but I appreciate all the arrangement for this online event and let's hope it will be possible in the near future. So today I would like to introduce some background and current status of general UAV application in Japan and application for agriculture and forestry. So as most of you are probably not aware of our company, let me spare some time to introduce a little about Kokusai Kogyo. We are a survey company in Japan founded in 1947, right after the World War II. We have about 2,000 workers and offices in each and all of the prefectures in Japan. And scope of our business is geospatial information service, GIS, disaster risk management and environment, infrastructure engineering, and renewable energy. We utilize various tools for the survey from underwater to ground, airplane, satellite mounted sensor, and we of course have many experiences in UAV. Our service now expands to not only survey, but to data processing, analysis, and consultation and application. So our core business is aiming for creating green communities for a sustainable future, and we have many overseas experiences as well. Also, let me introduce a little about myself. My name is Mariko Toda, and I graduated Hokkaido University in 2016. I studied forestry, and after graduation, I started working in this company, and I've been working in Kokusai Kogyo until now. I work as a GIS and remote sensing engineer. I've done some overseas forest mapping works, and currently my main job is doing forest lidar analysis for domestic forest. So as you can see from my history, my main field is forestry, and I'm not really specialist for UAV or have knowledge in agriculture, so maybe I talk more about forestry today, but I'll try my best to share what I know. So those are the topics for today. First, I will talk about some backgrounds, current status of UAV in Japan. And secondly, I will talk about the application in agriculture field, then go on to forestry field, and a little about our overseas experiences relating to UAV. So let's move on to the backgrounds. First, I would like to talk about 3 expected roles of UAV in Japan. So those 3 roles are expected to be played by the commercial UAV with the latest technologies such as cloud system, IoT, and AI. First role is probably the first thing that many people think of when we talk about using UAV. This role can be explained by taking pictures or videos or other information from the sky and using the data for decision making. Example of use are disaster survey, monitoring of agriculture fields, forest fields, aquaculture fields, and infrastructure inspection. And we are most experienced in this area as use of a UAV. Second is mobility for transportation. This is the role for transporting cargo or human using UAV. Example of use are delivery of medical supplies, management of 3D data or flight data, and human transportation, like flying car in the future. So as we have experience in creating HD map for automatic driving, we are likely to take important role in creating 3D data for flight area. So the compatibility with KKC is the second largest in this area. The third role is for robotics. Examples are chemical spraying in agriculture field, commercial and announcement in the city. You've probably seen this in many newses in this COVID situation, like telling people to go home from the UAV. It can expect it to be temporarily communication based in the disaster situation. So this role has the lowest compatibility with KKC, as this is more about hardware and we are not a hardware company. But we do have some experience in collaborating with the university to use robotics UAV to collect ashes from volcano eruption. Now I'm going to introduce about laws and regulations in Japan. The government has been discussing and organizing regulation and rules for implementing Level 4 invisible flight and living area in 2022. So it's already coming up next year. I'm not sure how you describe this in Taiwan. Maybe it's the same, maybe it's different. But we have several levels of flight for flying UAV. Currently, level 3 is allowed, and next level is level 4. And level 3 is invisible flight in non-living area. So if you're in forest or agriculture field where the people don't live in, you can do the invisible flights. So you don't have to have your eyes on the drone all the time. Level 4 is invisible flight in living area, and it is easy to imagine that this will be the key for utilizing UAV more in the city area. To enhance more use of UAV, regulations are being revised and new accreditation system for aircraft and license system for the operator are being developed. So after we have all those systems, when all the aircrafts are registered and all the drivers or operator have the license, it will be easier. It will make the application system easier since the government knows who or what they're doing. It is expected to become more simple and speedy. So now I will talk about the UAV related market in Japan. Commercial UAV is expected to grow to 450 billion yen scale market. Agriculture and inspection will be the main fields, and in the future it will be logistics. And there also the idea of city digitalization. You probably heard of smart city. Those are the idea that you create 3D data of the city to use for everything, and those data can be obtained by UAV. And this is accounted in the as a big role in UAV related market. So until now, I talked general things about UAV current status in Japan. And under this, now I would like to talk about under this situation, what kind of position that KKC are aiming for in this industry. So there are two major roles in UAV utilization that we aim and direct for. One is creating data from spatial information using UAV and various sensors. So this is what we do mainly. We are a survey company. We have experience in sensing, surveying, measuring, and this is what we're good at. So of course this is the major role in UAV utilization. Another one is implementing use of UAV and robotics using the data. So we would like to provide the data and provide the useful information for utilizing UAV and robotics. So that's two major roles that we would like to take in the UAV industry. So this is one of our UAV related service. It's called KKC 3D. It's a cloud service to create SFM, also image, 3D data, point cloud data online. The cons of this service is you can create survey level 3D data without any knowledge. And usually when you want to do SFM also analysis in your desktop or using your data, you will have to purchase the software to do the analysis. Especially if you want to create survey level data, you will probably have to purchase the expensive software. But using this system, as this is cloud-based system, you don't need to purchase software. And the processing speed is relatively fast, and the service will create report that is compliant to official eye construction manual. Actually, this service in Japan was created for eye construction, so it will generate the report that is compliant to eye construction in Japan. So it's probably easier to explain and understand how it works. So you take pictures from UAV in the ground of the ground, and you can upload the pictures in the cloud from anywhere, and then you just wait for a while, and then we generate the data on the cloud, and after a while, or a few days or a few hours, it depends on the size of the data, but relatively it's fast, you can download it from anywhere, and then you can use the data. So that was one of our service, but I would like to go back to the history of KKC USB business. We are a leading technology and business development in this UAV application in survey industry. As a survey company, we were pretty fast. We can call ourselves a pioneer for UAV application. In 2008, we started geospatial service using microdrones UAV. And for government movement, 2015, there were a revision of aero law. So that was when people realized that the UAV exists in Japan generally. But so we can call ourselves early, as we started the service way before that. And in 2016, the government started eye construction. The eye construction is using the UAV in the construction site. And to match this law and system, we start a drone school and start the KKC service, KKC 3D service. So KKC 3D is the service that I explained earlier. Drone school is the school for the operator to learn how to fly the drone, especially for the survey purpose and that is compliant to eye construction. So we provided this service for targeting the small survey company, that even for small survey company that cannot afford to buy any software for SFM analysis, or don't have any technicians to fly drone, they can join the drone school to teach anyone to be able to fly the drone UAV and survey level, and use of KKC 3D. They don't need any software to create the data that is compliant to eye construction. And in 2018, we started the investment to Drone Fund, which is the fund for startup companies of UAV in Japan. And in 2020, we operated first official level 3 flight. We have an agreement on local empowerment using UAV. We joined POC for using several aircrafts at the same time using UAV operation management system. So those are the history of our UAV related business. So till now, I've talked about the general status of UAV in Japan, but before I move on to the example of the application, I would like to summarize the characteristic of UAV application. So UAV are useful for the quick response, repeated shooting, and obtaining detailed imagery in relatively small area. So if you compare with satellite and airplane data, drone image is more suitable for covering smaller area. If you want to take the generate the data in a larger area, you probably want to consider using satellite image or aircraft. But for spatial resolution, drone imagery can get the very high resolution data as it covers smaller area. And also for temporal resolution, you can actually control it very well. If you think of getting the data today, you can even do it with UAV. So for temporal resolution, UAV is the best. And also it can avoid the effect of cloud, unlike satellite imagery. So now I will go on to application case in agriculture field. So UAV application in agriculture are mainly aiming for smart agriculture. So you probably have the same problem in Taiwan. The age of agriculture laborers are getting older. Younger people don't want to do it anymore because it's dangerous and it's hard work and it requires manpower. So the governments are trying to change it with using ICT and robotics. It will improve quality and safety of crops. It will reduce hard works and it will cut off labor. So they can get higher return with improved quality crops with less effort. So it will attract younger people and it will lead to sustainable agriculture. So those are the main purpose of UAV application in agriculture. And there are several UAV roles that are expected to be taken up. One is spraying, another is loading and transporting cargo, and the last one is data acquisition. And the government actually has several goals in 2020 for the spread of application. For agriculture, I think those are quite popular for spraying agriculture chemical and pollination probably. And as KKC, it's similar to what I explained earlier. We are mainly good at those data acquisition part. So this will be what I will be talking about mainly. So the agriculture chemical spraying is what I experienced. It's not really what we have experience on, but the cons of this application is you can spray large area at once compared to what you do from the ground, and you can cut off labor, reduce cost, and it can also be used for smallholders. This is our UAV related service in agriculture field. It's a crowd-based agriculture support service called Appare. It started from 2017. The service is similar to KKC 3D. If the farmers take pictures from drone, they can upload it and we will give them back the report of their current field crop condition. So this is the example of our analysis. This is actually the analysis based on satellite image, but we can do the same thing from the UAV image. So this is the image, and from the image we analyze each bands to map the protein contents. So high proteins are described in red and low proteins are described in blue. So this protein content is very important for making the tasty rice. It can't be too high, it can't be too low. So based on this protein contents map, they will be able to know where they need the additional fertilizer or where they need to harvest. Also, there are application in water drainage consultation. Because it can create 3D data from the UAV image, we can evaluate the drainage and microtopography and slope in the field. So it will utilize 3D data to analyze drainage of the field and microtopography, and the result can be used for drainage planning and land improvement. Now I will move on to the talk in UAV application in forest field. As KKC, our experience in UAV for forestry field is mainly as a remote sensing tool. In 2020, we conducted Level 3 survey in forest, which is conducting invisible flights in non-populated area. And this was the very first case when forest survey with Level 3 UAV flights were conducted. During this time, it took longer time and efforts to get permission for Level 3 flight, but these days the process have been improved a lot. And generally, aerial LiDAR is the most major method used in many local governments to obtain various forest data, such as species of the forest, height, age, volume, density, and so on. And my main work is also doing analysis of this kind of survey. With airplane, as I explained earlier, we can obtain DSM and DEM at once. DSM is the surface information of the forest, and DEM is the ground information of the forest. This is because the LiDAR will penetrate the forest and trees, so it can use surface information and the ground information at once. And by subtracting DSM by DEM, we can obtain the crown height data, which allows us to create more useful data for forest management. Using airplane is effective for the large area. And UAV can be used for creating data in cheaper and more easy ways for smaller area of forest. It is effective to update existing LiDAR data. So now many local governments are conducting the LiDAR survey with airplane. In the future, it is likely that we can use UAV to update those data. Where DEM exists, because DEM is unlikely to change very often, except where there was a big landslide or volcano eruption, we can use the same DEM once we get the DEM. But DSM will change because the tree will grow. So we can just update DSM to get the latest DCHM, which is the data of the forest. So DSM can be created by just arrow shooting by normal UAV. It doesn't even have to be LiDAR, which is expensive. But just with a flight and just a picture, we can create the 3D data with UAV. Because using drone is very cheap and easier, it is very effective to obtain the latest information in a small area. And this is applicable when you want to plan harvest or monitor the growth in the certain area. Use of laser drone has been becoming practical these days, although expensive. It is expected to be able to obtain height and tree location and DBH, the diameter of the tree, at once in high accuracy. It has been very difficult to obtain height data and location of trees from the ground because you can't really see the top of the tree from the ground when you're at the forest. And it was also hard to obtain DBH and underground condition from the sky. So drone LiDAR is expected to solve these problems and improve work and quality of the field survey. Although useful, there are several issues for applying UAV for forest. One is issues in matching for SFM analysis. SFM analysis is the analysis that they need to find the same spot in each picture, and they will do the matching by that. Because most of the forest is very uniform compared to the city, like all the roofs are the different colors, but in the forest it's all green and it's the shape is all similar. So it's very difficult to find the matching spot in different pictures. And also there's a wind and the shape of the tree can change in each picture. Then it will make it more difficult to do the matching. The second issue is a network issue. Most of the UAV now has RTK system with it, and it requires cellular network. So in the deep forest, when you don't have cellular network, you can't obtain RTK data, and the positioning accuracy can be bad without RTK. And the last issue is issues in finding departing and landing spot. So it can be hard to find an opening space for landing and departing spot in the forest. If you have road, maybe you can fly from there. And if you're flying a Phantom or Mavic Pro, it's relatively small, so you can even fly from your car. But for Red Edge or lighter UAV, it's huge, and it requires even larger spots for flights. So this can be the issue for applying UAV for forest. And I would like to talk about the trendy ones these days. So global warming has been one of the most important global issues all over, and expectation for forest role and storing carbon has been increasing. It's becoming a strong issue in Japan since last year when our Prime Minister Suga, now it's changed, but he declared that Japan will aim for zero emission by 2050. This has a strong impact for both the government in many levels and also for the private company. So various organizations are now seeking a way to quantify the amount of CO2 absorption by forests they own in order to offset the amount they emit. It's actually not an easy subject to quantify the amount of CO2 absorption by forest growth. Forest is very famous for absorbing CO2 by photosynthesis, but many people forget that it also emits CO2 by respiration. They also need to breathe like us. So only the difference between the absorption and emission can be accounted as CO2 absorption by forest. The amounts are also known to saturate at certain age, so it has their max at the younger age, and in old growth forest, emission can be larger, and forest can be a source and not a sink of CO2. So considering those facts, in order to measure CO2 absorption, we need to measure the growth of forest rather than how much carbon stock there is right now. So as explained earlier, UAV can be useful for obtaining the latest data, so it will be useful for comparing 2 seasons and obtaining the growth of forest. In the future, it is likely that use of drone in the area where aerial radar data already exists will become popular in order to estimate the carbon absorption of the forest and claim for the offset. So this is out of our experience, but I would like to introduce as an example of UAV application. So I don't know the case in Taiwan, but in Japan, 70% of the cost for forest management is spent in the earlier stage of the forest. And planting is also one of the most expensive work. And application of UAV at this stage, like transporting seedlings at the site, is expected to reduce the work and reduce the cost for whole silviculture procedure. So in the end, I would like to introduce a little about our overseas experience. UAV can be used for monitoring the site without actually accessing to the site. And this can be a very useful tool for monitoring illegal deforestation or confirming if the forest operation was done correctly. So it's a very useful tool in developing countries as well. So similar to drone school we used to conduct in Japan, we do some training in other countries to train operators to use drone, and we do the training both for the flights and also for the analysis. So it's coming to the end of my slide, and at last I would like to introduce Think Drone Limited. They are our group company, and they take role in developing KKC's technology in Taiwan market. So if you're interested in our technologies or experience or have any questions, but would like to communicate better maybe in Mandarin, they will be the window, so you can contact them. So this is the end of my presentation. I will be back in Q&A, but for now, thank you for listening.